Welcome back to Sri Sampath Vinayaka Learn Easy channel. Now we will discuss exercise 2.1 ma. Okay, in that first question Seema, which of the following are sets? Justify your answer is asking. Here the first question is the collection of all the months of a year beginning with the letter J. We know that it is a well defined set because whoever is going to list the names of the months, everyone is going to get the same list of months. Those are January, June, July. These are the 3 months which are starts with the letter J. Okay, so that is a set. Next, second question, Seema. The collection of the 10 most talented writers of India. It is not well defined. Why? Because there is no rule or no property that states who are talented. Okay, that's why it is not well defined. So, it's not a set. Now, the team of 11 best cricket batsmen of the world. Okay, so Seema, it is also not well defined because there is no rule that who are best cricketers. Okay, that's why it is not well defined. If I will write the list of best cricketers, I will get some list, some other person will get another list. That's why it's not well defined. So it's not a set. The collection of all the boys in your class. Yes, in that specific class he is telling. In that particular class, the boys is going to be a well defined set because in that class whoever is going to write the names of the boys, everyone will get the same list of the names of the boys. So that's why it's well defined. So it is a set. Next, the collection of all even integers is it is well defined. Why? Because in the world whoever is going to list out the even integers, they are going to get the same list of even integers. Okay, that's why it is well defined. As it is well defined, it is a set. Here the second question. If A is equal to set of 0, 2, 4, 6, B is equal to 3, 5, 7, C is equal to set of P, Q, R, then fill in the blanks with the appropriate symbol belongs to or does not belongs to, he asked. So, Seema, is that 0 there in that set A or not? Yes, that is there in the set. So, that's why I will write belongs to. 3 belongs to whether that C or not? No. So, 3 does not belongs to C. Okay, now. Is that 4 belongs to B? No. So, does not belongs to. Is that 8 belongs to A? No. It does not belongs to. Is that P belongs to C? Yes. So, that's why it belongs to. Is that 7 belongs to B? Yes. It belongs to. So, that's why I will use belongs to. I hope you understand. See, here the third question. Express the following statements using the symbols. Okay, the first question here is the elements X does not belongs to A. The element X does not belongs to A means simply I will write X does not belongs to A. That is symbolic notation. D is an element of the set B. As D is the element of the set B. So D belongs to B. 1 belongs to the set of natural numbers N. So 1 belongs to the set of natural numbers N. 8 does not belong to the set of prime numbers P. So 8 does not belongs to the set of prime numbers P. I hope you understand. Okay, na? Here the fourth question. State whether the following statements are true or false and justify your answer is asking. Here Seema, 5 does not belongs to the set of prime numbers is said. We know that 5 is a prime number. So, it's false. Actually, the justification here is 5 belongs to the set of prime numbers. Okay, na? Next. S is equal to 5, 6, 7 implies 8 belongs to S is said. In that S, is that 8 is there? No. So, it is also false. Because 8 does not belongs to S. Here also since 5 belongs to P. Here Seema, negative 5 does not belongs to W. Here W is the set of whole numbers. We know the whole number starts from 0. 0, 1, 2, 3, so on. So there is no negative value. So minus 5 does not belongs to W. Yes, it's true. Since negative 5 does not belongs to W. Okay, Nama. Next, 8 by 11 belongs to integers is set. Okay, now we know 8 by 11 is a rational number. There is no rational number placed in integers. So it is false. Why ma it is false? 8 by 11 does not belongs to integers. That's the reason. That is our justification. I hope you understand. The fifth question. Write the following sets in roster form. He gave the sets in set builder form and he is asking us to write in the set roster form. See ma, x says that x is a natural number smaller than 6. Then tell me the natural numbers which are smaller than 6 ma. 1, 2, 3, 4, 5. This is our answer. Understand ma? Next. Here see. He gave that x says that x is a 2-digit natural number such that the sum of its digits is 8. Sum of the digits must be 8 and that must be a 2-digit number ma. So simply here I will start with see ma. 17. Sum of these 2 digits is 8. Next 26, 35, 44. Next 53, 62 and 80. Okay na ma? And here 71 also. 71, 80. These are the 2-digit numbers whose sum of the digits is 8. Now the fourth one here see. X says that x is a prime number which is a divisor of 60. That means prime factors of 60 I want. So simply do prime factorization ma. 2 30s are, 2 15s are, okay na? 3 5s are. So what are the different factors ma? Prime factors of that 60? 2, 3, 5. Okay? X is a prime number and that must be a divisor of 60. That means prime divisors of 60 we have to write. Okay na? Next here see. X says that x is an alphabet of the word, okay na? Better. So I will write B, E, T, R. Why? Because this T and E are repeated. We know those are not going to be repeated again in the set. Why? Because in the set repetition of the elements is not allowed. I hope you understand. Sixth question. Write the following sets in the set builder form. He gave the sets in roster form and he is asking us to write or express in the set builder form. Here the first question is, let A is equal to 3, 6, 9, 12. Simply I may write this one as, see ma, x says that x is a multiple of 3 less than 15. I may write like this. X says that x is a multiple of 3 less than 15. Okay. Or I may express this set as, see ma, 3 into 1, 3 into 2, 3 into 3, 3 into 4. Need not to write this one ma. Okay. Just you have to assume that one in your brain. Okay. Now mentally you have to assume that. Now see here, every element of that A are like 3 into something. 3 into 1, 3 into 2, 3 into 3, 3 into 4. That's why every element of set A are like x. And x is like 3 into something. 3 into something. Instead of that something I am taking k. And what is this k ma? 1, 2, 3, 4. So k is a natural number. K belongs to natural numbers. And k is have some limit. So that k is less than or equal to 4 ma. Okay. I may write in this way also. Okay. Now coming to that second question. Set B is equal to 2, 4, 8, 16, 32. Here I will express that 2, 4, 8, 16, 32 as, see ma, 2 power 1, 2 square, 2 cube, 2 power of 4, 2 power of 5. Here the changing value is the power and the base is constant. So simply I will describe each element of this set B like some x. All the elements of the set are like x. And x is like 2 power of something. 2 power of something. Here that something is 1, 2, 3, 4, 5. That means that n is natural number. And that something is having, something is having some limit, that is less than or equal to 5 ma. Okay, now coming to this, here see ma, this is also expressed as 5 power 1, 5 square, 5 cube, 5 power of 4. You need not to write this step ma. You have to assume this step in your brain. Simply write all the elements of this set are like, let us suppose y, and y is like some 5 power k. You may write any variable ma. You may write k, you may write n, you may write p. Okay na. The variables which are not used here, you may use any variable. Okay. Now y such that y is equal to 5 power of k, and this k is, see ma, the changing values are the powers, so that k is a natural number, so k belongs to natural number. Again this k is having some limit. Okay, k is less than or equal to 4. Similarly here see ma, here this set is, let us suppose it is d. Okay na, all the elements of this set d are like 1 square, 2 square, 3 square, 4 square, so on 10 square. That means the changing values are the bases. Okay, so simply I will describe this set as d is equal to, okay na, all the elements of this d are like some y, let us suppose, and y is like, okay na, something square, y is like some n square, and that n is a natural number, n is a natural number, n is up to 10 only, so simply I will write n is less than or equal to 10. Okay, in this way we will write the given roster forms into set builder forms ma. These bits are very important. I hope you understand. The 7th question ma, write the following sets in roster form. He gave us the sets in set builder form. Now we have to write them in roster form. Here see ma, x says that x is a natural number and greater than 50 but smaller than 100. I have to write all the natural numbers which are greater than 50. That means 51, 52, so on. Smaller than 100 means up to 99 I have to write. Understand ma? This is our set A. Okay, now set B here see ma. X says that x is an integer, okay na, which satisfies x square is equal to 4. X square is equal to 4 means x is equal to plus or minus 2 ma. X is equal to plus or minus 2 means here I have to write minus 2 and plus 2 both, because x is an integer we said. Coming to the third question. Here if it is a natural number, then I have to write only plus 2 ma. Why? Because negative 2 is not in the natural numbers. That's why this condition is important. As he said x is an integer, I have to write both positive and negative. Let us suppose it is a natural number, then I have to consider only plus 2 here. Okay. Now D. Here see ma, what is said ma? X says that x is a letter in the word loyal. Then into the D I have to write L, O, Y, A. Okay na. Again that L is not written here because that L is again repeated. Okay na. That's why repeated letters are not allowed in sets. I hope you understand. The 8th question, the last question of the exercise. Match the roster form with the set builder form he asked. Firstly, to match the roster form with set builder form, we have to write the roster forms of the given set builder forms. Here see, x says that x is a prime number and divisor of 6. That means I have to write the prime factors of 6. What are the prime factors of 6 ma? 2, 3. Okay. Now, here x is an odd natural number smaller than 10. I have to write all the odd natural numbers which are smaller than 10. 1, 3, 5, 7, 9. Okay. Now x says that x is a natural number and divisor of 6. Now I have to write the factors of 6. What are the factors of 6 ma? 1 6 are, 2 3 are. So these are the factors. So into this I will write 1 2 3 6. Next here x says that x is a letter of the word mathematics. So what are the letters comes into this ma? M, A, T, H, E, I, C, S. Why? Because no letter is repeated in the set. So after converting the set builder forms into roster forms, we have to match them. See ma, 1 2 3 6 is matched with the C, and now this 2 3 is mapped with A, and mathematics is mapped with D, and this 1 3 5 7 is mapped with B ma. Okay, like this we have to match. Okay. I hope you understand. Thank you for watching. Please share and subscribe.